Greetings, Earthlings. What you see here is a B&K Precision Model 501A semiconductor curve tracer that I just got off of eBay. And so we're going to set it up here and see if it even works. It was sold as used, but not tested. But used is supposed to mean that it works. For parts or repair means that it doesn't work. So used, not tested, that's always iffy. So we're gonna take a look here. Looking at the instructions here, the first setup for the oscilloscope, we'll use this oscilloscope here, Tektronix 2236, and I have it in XY mode, okay, which is how you use this thing. So the first thing we're going to do is we want to do a vertical calibration. Okay, so we set the Y, connect the Y input, which is channel 2 here, to the base or gate input. And we're supposed to set the step selector to 0.2 volts, and then it'll generate a 1 volt trace consisting of 6 dots, each spaced 0.2 volts apart. I have it set on 0.1 volt for the moment, but we'll see. We'll see. And so, and it should be, let's see, okay, so 0.1 volt, it should be 0.5 volt switch. I'm currently on 0.2 volts, 0.2 volts per division. So 0.5 would be, let's see, now this is complicated. Half a volt per division, If I set it on 0.1 volt per division, how about that? 0.1, then 0.5 is 5 ticks, okay? So let's turn it on before we burn a spot in the screen. Yeah, okay, yeah, so it's volts per step, not current per step over here. Okay, so we're pretending that we're testing a field effect transistor. The X input is grounded. We're just gonna get a vertical line. And so turn it on. And yeah, we got a vertical line. Okay, with 1, 2, 3, 4, 5, 6 dots. But they're not evenly spaced, that's for sure. And it should, like I said, it should be 5 divisions. 1, 2, 3.06, 3.6 divisions. Definitely not 5 divisions. Let's see. From here, 1, 2, 3, 4, 5 would put us to the top line. So it should go from here to here, evenly spaced. It's not. Okay, that's a problem. Well, let's test it the way they said. You go to 0.2. Same thing. Let's see. It's set on PNP right now. PNP or P channel. Let's set it to N. Oh no, it's set on N channel. Let's set it to P channel. See if that makes a difference. Well, yeah, it inverted it, but it's even worse. That's just 2 divisions, not 5. Okay, so definitely there's a problem here. See, and then what I'm supposed to do at this point is, if that's calibrated, okay. That's calibrated at 0.2, so that's a little better. What I'm supposed to do is set it to span, well, you want to have 10 divisions. And then set the dot on every second division. I only have 8 divisions vertically. But even so, I can't see if I were to go like that. There's from top to bottom. Again, definitely not evenly spaced, so that's defective. So, well, we cannot proceed with the setup. We can look at maybe other signals. Where's my schematic here? Okay. I have the schematic. We're not going to open it up at the moment, but what should be on the vertical output is this trace here. Can you see that? Can you see that? I hope you can see that. Okay, it's sort of a, what's that, a half wave rectified signal, but it's the lower half of the signal, or it's inverted from, yeah, because that is there, and that goes straight there to the vertical. Okay, so if I reconnect this, well, let's switch. Okay. Okay. And yes, I know I should calibrate the thing for the channel it's on. Okay, oh, this is fun. Okay, there's our stair step. It's supposed to be going, oops. It's supposed to be going up, not down. Okay, that's a problem. And again, you can see that the steps are not even. Okay, so that's inverted from what it should be, which is really odd. This is switching back to NPN to see if it makes, oh yeah, see if that makes a difference. Well, what is this? This is different. No stair, oh, there's a stair step. Okay. Well, okay, that's a climbing stair step. So it may have just been that I had it set on PNP. Okay, but again, woo, not even at all. But I wanted to change this and look at the vertical output. Well, actually, let me put this back here. I already have this other channel connected to the vertical output. So let me go ahead and plug that in. Okay. And that looks about like what it's supposed to look like. Or is it inverted? See, that looks like that. If I switch it to NPN, it looks like that more or less. Oh, well, okay. The schematic does show it set in PNP to show these traces. So PNP, that is the correct trace. Okay. So that seems to be basically working, and I can vary the, or attempt to vary the level, yeah? That seems to work. That looks okay. But we've got a problem here in the stepper circuit, which I think is probably fixable. Well, of course it's fixable. It's just a matter of, are the parts available? The only hard parts to find for this would be replacement switches or sockets, I think. The The transistors are just generic PNPs. There's some precision resistors here. Those are easily replaced. This is standard TTL stuff over here. 7473s. These are 7402s. So, yeah, my reading of the schematic says that this is what we should be seeing. This comes down through here. This is some sort of voltage divider or something. And then comes right up here and goes to the base output, which also is the horizontal output to the oscilloscope. So, switching back, did I disconnect that? Let's try this. Okay. What? Right. Oh, I see. Yeah. Well. Wait. We want to see the waveform. The waveform should be, again, set on PNP, should be an increasing stair step. Let's try turning that the right way. Let's see what's going on here. Let's try that. Okay. Hello. Where is you? Where are you? Okay. Why do I make it so hard on myself? Okay. There we go. It should be an increasing stair step. It's a decreasing stair step. So I'm looking at the schematic here, and I see. This is a guess at this point. I haven't opened it up. I haven't checked the other signals, but I see an inverter here. Okay, there's a buffer. This is basically a digital to analog converter and a counter. Okay, that creates the stair step. And this is an inverting amplifier. And if that's dead, then it won't invert, and then we would get an increasing stair step here. Output of that comes back around to this, which inverts it again and gives us the upward stair step. So first guess is that op amp is bad. That's a 741, which I don't have on hand. But that would be my initial guess. So now the question becomes, should I complain to the seller? He indicated that he had not tested it, but he also sold it as used, not for parts and repair. Had he listed it for parts and repair, it might have brought a lower price. As it is, the price was reasonable. It was about half of what these units are selling for in known working condition. So I think I have no reason to complain, except to perhaps inform the seller that he should be more careful as to his description, because the reality is, on eBay, the responsibility is on him. If he lists it as used, he's essentially guaranteeing that it's working, and it could come back at his expense. Even though, I mean, also in the listing it said he accepts 30-day returns, buyer pays return shipping. But this would be a SNAD claim, significantly not as described. and as a seller, he would lose that because it is not working as, it is not functional. It's semi-functional, but it doesn't. That doesn't. It can't be. It can't be. It can't be calibrated. So it's not. It's not. Fully functional. So again, that's on. That's on a seller, but because I think it's a simple problem, I don't think I'm going to hassle the guy.